Welcome to Akhand Vidyashram, the first institute of impeccable wisdom, the walking, talking encyclopedia. GFR, the glomerular filtration rate. My dharma, the impeccable wisdom, the wisdom of the divine nature. My greatest discovery, Divyank, the divine design of nature with which the perfect objects are designed and created. Divyank is the reward of 60 years of integrated knowledge. Impeccable wisdom is enlightening. Akhand Vidya wisdom is empowering. We started section on excretion, elimination of waste products from the human body. And from that angle, let's first understand functional anatomy of the urinary system. We have two kidneys, two ureters, one urinary bladder, and one urethra. Male urethra is long and female urethra is short. This is a gross structural anatomy of the urinary system. The functional anatomy of an integrated human kidney, as I've made it clear in the last slide as well as this, is kidneys are bean-shaped in the ratio of Divyank ratio. The length and breadth like heart is in Divyank ratio 3:5. It is surrounded beautifully by capsule, and inside we have the cortex, outer layer, and you have a medulla which is inside, and then you have calyx, and then you have urinary pelvic region, and all the ureters coming together to form ureter, and urine is carried to bladder and excreted out at regular interval. This is middle level of structure of urinary system. Third system which I have told you, the anatomy of the human system. The anatomy has got outer cortex and inner medulla. Cortex is always the outside, medulla is the middle side. And 80% of the cortical nephrons are in cortical area. They are the one which are responsible for formation of urine as such, glomerular filtration rate. But inside you have just a medullary nephron, which prime structure is in the cortex, but something is extended, or later part of nephron is extended inside the medulla part. The difference between structure of your collecting system in nucleus is just, let's say, anterior arteriole, capillaries, and exterior, and then Broman's capsule, and then urine is formed. It's reabsorbed, excretion is done for the concentrated, and then whole thing is collected as such and passed on. That is something which is found in cortical region. But in juxtamedullary region, you have vasa recta, and you have loop of Henle longer than what you find in cortical region. The idea is between the two, you have a vasa recta, which is a capillary system between descending and ascending loops of Henle, and from there concentration of urine is done, and urine is more concentrated and done with it. Since we are talking of glomerular filtration only at this particular juncture, we are not talking of concentrated urine. We are just formation of urine, the filtration. So we are going to more or less concentrate on what is normally found in cortical nephron in this particular structure. I'm sure this is very clear from this particular picture. We are going to focus on glomerular filtration rate primarily, which is 80% in cortical nephrons. How the urine is formed to start with, what happens later, we will leave it for the later part. Let's go to the next. All these slides I have already shown in the last one. You can now very clearly see you have afferent arterioles which bring plasma or the blood from the system to the glomerular capillaries, and from there it goes to efferent arterioles. Both are red basically because there is no use of oxygen to convert oxygenated blood into deoxygenated blood, so it has to be red alone. Only what we see is a filtration here from higher concentration, low concentration through the passive process, not through an active process. From higher concentration, low concentration. And as a result, you have 4 stages of urine formation. First stage is filtration or ultrafiltrate, and then reabsorption of essential things which have been filtered out, because glomerular filtration with a passive, and anything up to the size of 4 micron size can easily pass through the structure, but they are the useful like water, glucose, amino acids, minerals, etc. You can't waste all of them, including electrolytes. Sodium is to be reabsorbed and potassium maintenance has to be done. Even other chemicals which need to be reabsorbed have to be reabsorbed. As a result, you have reabsorption, the second step. But anything which is larger than that, which is wasteful for the body, needs to be expelled, has to be excreted out with the help of secondary process or active process with the help of ATP. Here concentration is not from higher concentration, lower concentration. It is pushed out with the help of facilitating forces to make sure, like sodium potassium pump comes with the ATP. Glucose and sodium are symbiotic. Potassium and amino acids, sodium, potassium and sodium are also symbiotic. Many of those things I've already spoken in homeostasis earlier. What are symbiotic relations? What are contributed? How they move? Because now one by one we need to understand and apply that knowledge hereafter. Third stage of that excretion of articles which are larger than 4 microns or 8 microns cannot go through ultrafiltrate. Has to be pushed out. They are pushed out, and after the urine is excreted. So, and urine excretion will be equivalent to, as I've written, the filtration minus reabsorption plus excretion is what is absolutely essential as far as glomerular filtration is concerned. We are not talking of concentration, we are not talking of the other project other than just reabsorption of essential things, and excretion of what cannot be filtered is primarily in cortical nephrons. Let's go on to the next stage to understand this concept little more clearly. First picture is same what I've shown it last. It doesn't need, but you see the bottom part. You can see left side there is a plasma in the capillaries, and then you can see the capillary endothelium. Those cells, distance or filtration slit between two endotheliums are of 8 micron size, or it could be around that. That is second layer after the plasma, and plasma is flowing through that out. But after that you have a third layer called basement membrane of Bowman's capsule, which you see as a layer. But everything can pass through that. But then you have the next stage is food process of podocytes or glomerular capsule or Bowman capsule. So from that you can see the slit is narrowed down, is not as wide as you see in endothelium of 8 micron size. It is almost like 4 micron size. And that is something which I wanted to highlight and show you why filtration slit and filtration diaphragm and filtration capsule size is of 4 micrometers only. And you can also see the basement membrane, third one. Then you can see the podocytes, and then you can see the cells and how urine is formed and pushed to be pushed out of the body one by one. Now, for the dynamic of filtration rate, let me also tell you, it's very interesting in this particular process as the afferent arterioles which bring blood to Glomerulus capsule, you have a glomerular hydrostatic pressure which is equivalent to 60 millimeter of mercury. And you also have a glomerular colloidal osmotic pressure of 32 mm of mercury. Now let me explain what do you mean by glomerular hydrostatic pressure. We know when we talk of hydrostatic pressure, it is primarily because of water. And although it is written 60 mm, it could be 61.8034% according to Deviank, but it's close by. Let me leave it at that. And it is because of the presence of water in urine and the capillaries and the plasma. You have a hydrostatic pressure of 61.8 millimeter. And as far as glomerular colloidal osmotic pressure is concerned, these are the colloids, are those osmotically active particles which can produce pressure. These are proteins, primarily albumin, in the blood. As a result of that, you have 32 millimeter of mercury as a pressure, which is bringing the blood, keeps the blood within the capillaries, and the hydrostatic pressure, the size being small, passes through. Colloidal is the protein which is hydrostatic and it has a tubular structure, is a thicker, cannot pass through those slits, it remains inside. Only less than 4 milligram can. Since they cannot move out, they maintain the pressure of glomerular colloidal osmotic pressure within arteries. I'm sure these two elements are very clear. But then third stage, Glomerulus capsule pressure is 18 millimeter. I have spoken about water element. I have spoken about the protein element. But then you also have electrolyte balance and other things which are also found in Glomerulus capsule. They produce a pressure of 18 millimeter of mercury, which oppose the movement from this side. Now the three main elements play a very important role to move ultrafiltrate from glomerular filtration rate into the Glomerulus capsule to be excreted out. But now let's come down to the little net filtration process is equivalent to 10 millimeter of mercury. How is this calculated? Is equivalent glomerular hydrostatic pressure of 60 mm minus Glomerulus capsule of 18. That means it is 42. And minus the 32 of glomerular oncotic pressure or colloidal pressure, the result is 10 milligram. Because the difference in pressure between intravascular capillaries in the Glomerulus capsule, glomerular capillaries and Glomerulus capsule is difference of 10 as a result from higher concentrations in the capillaries in glomerular filtration easily can pass from up down by higher concentration itself, and as a result you don't need any facilitating mechanism like ATP or other mechanisms in one form or other. So that way I think it's very clear why glomerular filtration is from higher concentration, lower concentration. What goes into the formation of these processes is something which I want everybody to understand. And I can definitely say, in my opinion, this law of physics is mathematically correct, is applied everywhere so that we can lead life in a perfect way. So I'm sure you are able to understand glomerular filtration rate of 125 ml per minute and 180 liters 24 hours is because of this particular difference of 10 milligram of net filtration. From 60 minus 50 is equivalent to 10. So I'm sure it doesn't need any more further explanation. I think step by step I have brought it very clear. You have two kidneys, two ureters, one bladder, one thing. Then you have lumen capsules, cortical, and gesta maxillary in the medulla part. And the concentration from higher to this is the 4 stages, and this is the active process. I think from that, all the process one by one have been explained very clearly. It should not be any difficulty for anybody to understand. This is why glomerular filtration rate of 125 ml per minute, 180 liters, out of which literally 99% is reabsorbed, only 1% is excreted through the concentration, which we will talk in the next video or video later. So I'm sure gross structure, microscopic structure, macroscopic structure, and dynamism of physiology has been well cleared here. So now let's go to the next. This particular ideal systemic circulation I have shown earlier also. The amount of blood which is carried from heart to the rest of the system of 5 liters is divided 0.7 liters to the brain, which is 14%, but the ratio of brain is higher, so you literally get 55 ml for 100 grams of brain. Heart is the second in line. It's a 0.2 liters, 4%, but 70 ml per 100 grams is supplied in the heart. Liver and digestive is equally important. Brain is the master control. Heart is the one which takes care we survive. Liver and digestive system is very important because whatever is required for the 100 trillion cells have to be produced by that. So that is again 100 ml per 100 gram is the ratio, which is 1.35 liters, is almost 27%, has to go to the system which helps in ingestion, digestion, absorption, assimilation, excretion, and also detoxification of all the unwanted things in liver. And then the material which is used is brought to heart and then carried to kidneys for expulsion. And kidneys carry almost like 1 liter, which is 20% or could be 22%. But the ratio of size of kidney is much smaller, and it is 400 ml to 100 grams of kidneys. You can understand how concentrated, how effective, how efficient is this particular intelligent organ, which is able to give us almost all the changes with respect to homeostasis, A to Z, whether it's the blood pressure, 120/70, cardiac output, blood volume, heart rate, and also the requirement for hemoglobin, for oxygen as erythropoietin, or for blood pressure, aldosterone, renin, angiotensin things. We'll be talking about all these processes one by one as a separate one so that we can understand the concept very clearly. These are the foundation which I want, which I would be covering as later so that you can build on more as we move on. And of course, skeletal muscle, skin, and bone are other part. But right up to kidney, it is 400. That means percentage of blood carried to kidneys is much more than even vital organs like brain, heart, digestive system is kidneys. So importance is very clear, and I think if we are able to understand that, you will understand why glomerular filtration is 125 ml per minute, 180 liters, out of which 99% is reabsorbed, 1% is excreted after concentration, and that makes sure that all the biophysical parameters, which are 10 in number, are well taken care by kidneys by understanding to maintain intelligently the blood volume, cardiac output, and diastolic volume, stroke volume, efficient thing, blood pressure, heart rate, everything to connect with everything, including oxygenation and all the vital material. Or from that, we are going to see that one by one hereafter. This is only foundation. Having understood this, let's go on to the next. This is the last picture which I want everybody to understand is this. In process to make whole system very efficient, kidneys are by and large functional organs. They do not need sympathetic and parasympathetic as such. They are chemically motivated to make sure that we have absolute no problem whatsoever in maintaining biophysical manner, and chemistry can take care of. And if anyone who wants to be perfectly physically healthy, emotionally stable, mentally powerful, and spiritually integrated, have to make sure that he and she is careful about the amount of water in the body, which should be 61.8034%, and all the electrolytes, all the nutrients, everything in the ratio which is recommended by Divyank. And emphasis is that we are talking about a perfect human anatomy, physiology, biochemistry, psychology, to be lead a perfectly healthy life, even our 50s, 60s, 70s, 80s, 90s, and 100s. And that's the message which I'm trying to give it through these videos. Since I have explained step by step, I think this is more than enough at this stage. We'll build on this in next stage to prove why all the organs are important, why we need to take care of all the organs, all the 33 crore gods and goddesses of different nature which Vedas, Upanishads, others talk about it, have to be understood completely if we want to be like a living God on the earth. From that angle, I will leave it. So anyway, thank you very